Hi, Gabrielle. It's Wednesday, October 14th. All right, so we're going over quotient rule homework. All right, guys, so I heard 19.
Two.
Oh, and 2? Okay. All right, so let's first look at 2. So what was perplexing you guys with 2?
The square root. Yeah.
Okay, the square roots. Get this situated a little better. Okay. All right, so problem number 2, it's asking you to solve it 2 different ways because they're wanting you, again, to recognize that there's more than one way to do these problems, okay? But of course, you would want to choose the simplest way to do the problem, okay? So did you have a problem doing the quotient rule?
Yeah.
Okay, so let's look at it with the quotient rule. So could you tell me what you got when you used quotient rule?
I'm just racing.
Oh, did you? Okay. Can somebody tell us what they got when they used? Here, let me go ahead and put the function up here.
The question would just be the bottom of the square root of x squared and the square root of x.
Okay, so first, sorry, go ahead, Ruby. Now, what were you were saying? So the bottom would be squared. That's correct. Okay. Now you have a choice here. If you leave it in this form, okay, you've got 3x times square root x. You'd have to use product rule, correct? Because that's a product. And you're going to find sometimes we are going to have to use product rule within quotient rule. Okay? But I myself would say, why don't I simplify this? Because they have the same base, correct? All right? So if this is x to the 1/2, what's an x times an x to the 1/2? So, I'm sorry, Elizabeth, say it a little bit louder. It's going to be 3x to the, right, 3 over 2. Okay, so it might make sense to simplify. So again, I'm always going to stress, if you can simplify before you do anything, simplify, right? Okay, that goes even without math, right? Okay, so, and then I could leave this as x square root x, or I could write it as x to the 1/2. It's up to you. Okay, so we could immediately see the second way, because I actually can divide these both, correct, and then use power rule. That was the second thing they wanted you to do. But if we don't do that, and we use quotient rule, we're going to start down low. So x to the 1/2 squared. Think about that. What's square root x times square root x? That's x, correct? Okay? So I'm going to have x, and then I'm going to have x to the 1/2 right here, times the derivative of the numerator. So how about, Gabby, what would be the derivative of this numerator? So derivative of x, 1, good, minus,
Would be 3 times 3 halves.
that's right, so it'd be 3 times 3/2. This is where, good, which would be 9/2, good, and then x to the, I think you're minusing a 1, so minusing 2 over 2, so good, x to the 1/2. Okay, this is where I said those those fractions are going to come in, okay? So I'm not going to write that step. You got to kind of start to recognize it's going to be 3 over 1 times 3/2, okay? We're multiplying across. Minus, now the numerator stays the same, correct? Now notice there's 2 terms here, so I'm going to make sure I put that in grouping symbols. And then it's going to be times by the derivative of x to the 1/2, which, Sylvia, would be? Okay, so good. 1/2 and then x to the negative 1/2. Okay, so now I got this nasty looking mess. Let's factor, right? Again, we're gonna try to factor here. So I've got, this is all one term and this is another term. And I think what I'm going to actually do before I could right now factor out an x to the negative 1/2, but I think I'm going to go ahead and distribute. Okay, and I'm going to try to combine like terms. So Marco, would you distribute for us here? Very good. Okay, so we keep going over here. To the 1/2, good. But then I'm going to have that negative, correct? So I'm going to be distributing a negative as well. So I'm going to have a negative 1/2 x to the 1/2. Okay, why is it 1/2? Because Marco added those, correct? All right, okay. Then he's going to distribute here. What are we going to get? Good. 3/2 plus a negative 1/2 would be x to the 2/2, which is x. Then we have a negative times a negative. It's going to be positive. All over x. Okay. So now I'm at this point. And I think I'm going to look, it looks like these two are like terms, correct? So this is a, really this is a 1 x to the 1/2 minus a 1/2 x to the 1/2. So that's going to be a 1/2, good. So I have a 1/2 x to the 1/2. And these two are also like terms. So a negative 9, thankfully they have the same denominator, that makes life easier. So negative 9 plus 3 is 6 over 2, correct, which is 3. So good. All over x. Okay, last thing I'm going to do is go back and divide both of those by the x, okay, which I'm going to let you finish that. Okay, who could tell us what they got for the answer? About Elizabeth, what'd you get? Well, the very last answer, right? What are we going to have? So we'd have 1/2 minus a 1, which would be, so good, x to the negative 1/2, and then the x's cancel, plus 3. Okay. Now, if we went back to this original problem, which could I get, Ruby, would you shut the door for me? Sorry, it seems like there's an awful lot of, trying to keep it open because it's so hot in here, but it's, if we go back to right here where we simplified, right, at this point, okay, so I have the original function right here. Could I right now just divide both of these by the x to the 1/2? Yes, I could. So right now, I actually could simplify a little bit more. So the point of this problem was to get you to not just jump to quotient rule anytime you see a quotient, okay, which is what some students tend to do. So they just say they see a quotient, okay, quotient rule. No, first look at the problem and say, can I simplify it, okay? And if you can, do that. Because notice right here, if I divide 1 minus the 1/2, well, that was x to the 1/2. 3/2 minus a 1/2 becomes a 2/2, which is a 1, correct? So I have minus 3x. I'm right here. Now all I got to do is take the derivative of that. Okay, and that's really easy. That's 1/2 x to the negative 1/2 minus 3. Okay, so compare this amount of work to this amount of work, and which one would you prefer to do? Okay, the second one, at least I would. Okay, and notice we got the same answer. Oh, do I have a minus there?
What did you get on the first one?
How did we end up with a negative? That's what I'm...
I think it was the fractions, the 9 halves. 9 halves.
Oh. You know what? I'm going to have to go back and look. Yeah, was it right here? Ah, thank you. That. Yeah, right here. Yep. Ooh, gosh. Got to be in here. Okay. Okay, yes. So thank you. I'm glad we noticed that. That should be negative. Okay, great. This is why... Get away from me, B. Oh, great. Now there's a bee in my room. It's going to bother me. I hope nobody's allergic. Okay, all right. So 19 was the other problem that Sylvia asked about. Okay, I'm not going to actually do 19, okay, because I'm actually going to be collecting this homework at the end of the period, so you will get time. But look at 19. Does this look very similar to the problem that we just did?
Yes.
It does. Could we divide these by v? Yes. So 19, I would not suggest using quotient rule. Okay, I would suggest simplifying that first if you can. All right. Okay, the other one that was mentioned was, somebody else mentioned 28. Okay, so 28, you're going to have to use product rule. So I'm going to let people. Is there a problem where the product? Is there a problem where the product rule wasn't working? Is there somebody? Because this doesn't look too difficult to use the product rule. Okay, so I will let people finish this, not at the moment, okay, but you will get to work on it, all right? Okay, all right. What we're going to do today, okay, is practice a little bit more with the product rule. However, with a table, and then we're going to do some more problems, okay? This homework I am going to collect at the end of the period. Yes, and yesterday's too. I can have Elizabeth, my TA, she can go through the period and make you. Oh, you are? Okay. Well, I can do it during lunch. It's all right. Because Cameron and... No, it's all right. It's okay. I want you to be here while we... Okay, so this is... This problem is kind of like a problem that you would see... And let me say to Gabrielle. Gabrielle, I'm going to be... scanning this to you later today. All right, so you'll get it as an email. All right, so this is the kind of problem that you might see. In fact, you're going to see a problem like this on the AP exam. Where they're going to give you a table of values, and you're going to have to figure some things out from that table. Okay, so we want to start to get a little bit, but when you first see it, it's definitely a little bit strange looking. Okay, so what is this table when you look at it? What is the information that it's giving about Alfredo? What is this table giving us?
Giving us like the x will be the inputs.
Okay, so it's giving us our inputs, our x values, and then it's also giving us the outputs, right? F of x and also g of x. So we got two different functions. And then it's also giving us the derivatives. Okay, good. So we're kind of clear what we've got. And it even says this isn't a lot of information. For example, we can't compute the derivative at 3, right, with any degree of accuracy, but we're still able to figure some things out using the rules of differentiation. So what looks kind of weird is this notation. At least I know when I first saw this, this looks kind of weird. So I have h of x, now I have some other function that's not even in that table. And they want me to figure out what h prime at 0 is. But that's not in the table. But could I figure out the derivative for h prime of x? Yeah, I can. In fact, if I look at it, it's e of x times f of x. So that's a product, correct? So if it's a product, I'm going to use product rule. Yeah, okay? So that's a product. I just don't know what f of x is, okay? In fact, that's going to make life a lot easier because I don't have to do any kind of computations, okay? So I'm going to first go ahead and write down, I'm going to use product rule, which is f g prime plus g f prime. Okay, so let's do it. First one is f, which is the e of x, so that's staying the same, times the derivative of the second one. In fact, let's even put a little, this is f, this is g. Okay, so what is the derivative of f of x? I don't know specifically, but I could say it's f prime of x, correct? I don't know what f of x is, but its derivative is definitely f prime of x. Okay. Plus, now g stays the same, which is f of x, times the derivative of that first function, which happens to stay e of x. Okay. All right, so there is the derivative. I could simplify that, but I don't need to because I'm trying to find this at 0. So I want to find this at 0. So I'm going to go back and put in 0. So that means wherever there's an x, I'm putting a 0. All right, so I'm going to have e to the 0, which I know people know is 1, but I'm just going to write it, okay, for now, times f prime at 0 plus f at 0 times e to the 0. Okay, now I got to go horizontal because I'm running out of space. It's okay to do, but we already said e to the 0 is 1. What is f prime at 0? So now that table comes into play. So good, f prime at 0 is 9, okay? So I have basically 1 times 9, 9. And then what's f at 0? So I got 5 times 1. So it looks like it is 14. Okay. All right. So I want you to now continue to do those next 4 problems. Okay, kind of working together. Okay, and I know these are kind of strange at first. All right, so we're going to work on that. All right. So Gabrielle, check the website for the homework for tonight, and I'm going to send this to you right now.